so that the forum is enabling industry input, requirements, resources, and expertise to foster the standards organizations to create metaverse standards faster and better. That's the hope. We want to help all of the standards organizations, service the needs of the industry. We're very pragmatic, focused on real-world, hands-on projects like interoperability testing, requirements, pilot projects, and tooling. And it's open to anyone. There's no participation fee. There's not even an NDA. Everything we discuss at the forum is public. And because we're not a standards organization, there's no IP framework. So it's proven to be very accessible to anyone who wants to join. The forum is being bootstrapped by the Khronos group, and Khronos is happy to do it. It's part of our non-profit mission. We're funding the initial boot up phase of the forum, but the forum, we hope, will evolve into an independent, self-sustaining forum if it proves to add value to the industry. So we launched in June. We had 37 founding organizations, which we thank, and the Web3D Consortium was part of the founding members, along with Khronos and many other organizations, including Meta, Microsoft, Adobe, Autodesk, Epic, and many others. Today, we're at 1,900 members and counting, so the interest in the forum was significantly stronger, I think, than anyone expected. And I think that's a good sign. It shows the interest in creating standards for the metaverse and the willingness to participate in helping them to be created. With so many members, though, of course, we need to be careful on how we organize. So what we have done in the first few months of the forum, we've gathered the interoperability topics that the members are most interested in, and we've created domain working groups that are working on these hands-on projects, and the output from those working groups will be publicly available. And here's some of the upvoting. 3D asset interoperability came out number 1. Interestingly, privacy security came out number 2. But avatars, digital twins, XR, all these topics are of strong interest. So here is actually the pipeline of the first batch of working groups that the forum is now hosting. We're creating a Metaverse Standards Register, a publicly accessible and updatable database of metaverse relevant standards. And then these various working groups: 3D asset interoperability between USD and glTF, digital asset management, that's more of the IP side rather than the 3D graphics side, digital twins, digital fashion, privacy and identity, and avatars. They're the first groups that have been formed. So the Metaverse Standards Forum is kind of unique. We're not aware of this happening anywhere else. So bringing so many companies together with the goal of fostering open standards. The wide membership gives us a strong base of gathering, gives us the expertise to gather meaningful input and requirements, and a kind of a captive audience to adopt and promote the output from the forum. Any forum member can propose and lead and participate in these domain working groups. So to encourage anyone here, including Web3D, to think, how could you leverage the forum to further your mission? And please participate. And the forum is there to help standards organizations fulfill their mission. And the forum is open to any organization at zero cost. So that was it. Hopefully that was useful. Again, we're honored to be a sponsor of the show. Wish we were there in person. Have a great time, and hopefully see you all next year. Thanks.
Thank you. Thank you, Neil. You have applauses from people here. Yeah. I don't remember who said that, but one philosopher back in time said that the good things about standards that there are many. The bad things about standards is that there are too many. So we created standard organizations for having people talking each other, and then we create a forum to have standard organization exchanging each other. That is the good progress. And having as a headline the metaverse, that would be very challenging. But thank you for launching that. So we will spend our afternoon discussing about standards. We will have representatives from other standards organizations, and let's hope that we will finish the day with some lessons and some actions that would be to be followed. And of course, this Metaverse Forum initiative is one of the good things that can put people together on the same table and build something meaningful. Okay, thank you again, Neil. Let's move on, and let me share the screen again. So we are now going in the workshop standards for Metaverse that will have two parts. Part that is more presentations, and we will start with Julien talking about UMI 3D, or I don't know if you call it differently. You will tell us. Then we have Yeshwant that will give a presentation about the haptics development in ISO, and I will finish this introductory part by providing you some details on the MPEG roadmap in 3D graphics. And the second part is organized as a panel with several persons that some of them will be online, some others will be in place, and I will introduce them at that moment. So I will go directly and give the microphone to Julien. You just have to put your PC here instead of mine and share your screen on Zoom.
So let's go. Hello everyone. So I will be happy to be there with you for this Web3D conference today and for this standardization workshop. I will be talking about UMI 3D today, which is one open source technology to create collaborative 3D experiences. And this technology, in our opinion, in the UMI 3D consortium and also at Inetum, is that the technology now reach enough maturity and stability to be proposed for some modules or part of it as standards. So that's why I'm there today to present it to you. Okay, so one word about myself. So I did my PhD at the University of Strasbourg. The topic was the creation of that technology called UMI 3D. So for sure, the PhD thesis document is available and free and open. And I'm not now working with two organizations. First for Inetum, as leading the XR department for the innovation of Inetum, which is a big company, a big French company, and now international, working as an IT integrator, consultancy, and also editor. And also coordinating the UMI 3D consortium. Of course, Inetum is one of the two founding members with the University of Strasbourg of this consortium. And so I will more talk today about the consortium, the objective, and the technology than about what I'm doing at Inetum. So the first question we have, and I think the talk this morning is a good introduction to this. So thank you to Epic Game for this. It's about which standards we need for the metaverse. And in our side, we're interested in 3 points. Standardizing interaction with 3D content, meaning all the interaction regardless to the device used by the end users, about standardizing avatar animation for collaborative virtual environment, and having the same avatars with coherent animation regardless to the device of the user. And also one part about browsing virtual world, meaning having, like for the web, one single application able to connect to any kind of virtual environment and to navigate smoothly from one environment to the other. Okay, we are doing this in the field of a consortium, which is a groupment of mostly French universities and companies, and you will find some very known people there, like Lynx, for example, or the OpenAir Cloud group. And the global idea was in 2019 to put our effort together to discuss about what should be this technology, what should be the roadmap, and we worked together in the specification and implementation of a first version of the UMI 3D framework. And it's now available on GitHub. I put you the link at the bottom. So for developers, especially for Unity developers for the moment, there is a way to try it with samples and so on. Okay, so as I said, the objective of UMI 3D was to create a framework to be able to develop 3D collaborative experience, to host them in the cloud or on servers at least, and to make them available to people at remote locations. And we see this as a first step to the building of an open metaverse, as the technology is fully open source and available on GitHub, even if still not standardized. Okay, so the global purpose is to use a common web protocol to communicate between one XR device, having a browser, and virtual worlds using a common web protocol for communication. So it's basically ending both the scene description, synchronization of the virtual environment, and also all the things related to real-time interaction in collaboration. And one global idea is to say there that the XR browser, which is developed specifically for each device, is doing a big part of the work by adapting itself, the interfaces, the 3D interfaces to the specificities of the hardware. Okay, so I put one slide about the different publication we did the past years, just for a researcher to be able to read it and to know what is behind technically and scientifically. So we started by working on generic interaction, and especially finding a generic data model to represent interactions that are possible with a 3D space. And after this, we studied the real-time collaboration more in detail around how collaborating in that kind of environment is possible and how to create that kind of experience. And it was before, for sure, all the hype around Metaverse at the time where we was just talking about collaborative 3D. Okay, so where is UMI 3D now? So actually, it's reached a good level of stability, and at least enough for Inetum, for example, to build its Intraverse platform on top of it, including so Intraverse. One word about it: it's a low-code platform for enterprises and organizations to build virtual worlds like digital campus, enterprise world for training, onboarding, and HR usage. So it's the same thing as the intranet, but for 3D, actually. And we developed first use cases around collaborative and remote training at scale, and also stuff like the video on the top, where we started some activities internally about design thinking in 3D with VR headsets, with people remotely. So just to say that the technology is not stable enough for a company, an editor, to create solution with this and to commercialize solution based on that technology. So I think it's the right moment to start discussing about standardizing part of it. Okay, So for technical people, I will just introduce the different modules that are eligible to become standard one day to give you the first element about how the global ideas that are behind. So the first thing we are working on is scene description and scene synchronization, in how to download a 3D environment on your device and how to keep it synchronized with other users. And actually, no surprise there, it's globally based on the glTF tool with an extension we've developed with the official extension format to add some specific things to UMI 3D, like declarative interactions, like IDs and metadata, enabling us to synchronize the scene better, and a transactional language that enables the web-hosted virtual world to stream changes to the connected users, regardless of the device they are using. The second point, which was the start of the technology, is about declarative interactions. It's the global idea that a virtual world will use a finite set of data models to describe its possible interactions. Like, for example, just telling there is an object, this object is grabbable, and after this, the VR browsers will be allowed to generate the interface to make the object really grabbable with the hardware it has. That's the global purpose. I have a little drawing to explain it. So the global idea is that you have a virtual world, which is the UMI 3D environment, hosted on a server. There is a cube inside, and there is a data model described in the VRST paper we did in 2017, enabling to tell this object can be manipulated with a specific data model. And on the environment code, on the server side, you have implemented a feedback, meaning when the object is grabbed and with that given movement, I apply a feedback which is synchronized again to all the users. So the idea there is to have a finite set of data to describe interactions, a UI generator on the browser side, and when the user is manipulated, the generated user, it sends an interaction request, and the virtual world, it generated a feedback. The global idea there is to be able to distribute new features, new interactions in virtual world without to update the browsers, without to distribute new code to the devices, which make the thing more generic, more maintainable for the long term. Okay. The third module of UMI 3D is around tracking an environment. And in that area, we focused on finding one generic data model to describe the user movement. So the global idea is that we are doing the work on the other road. We are starting from the XR browser, from the device, and each device is able to provide two kinds of data, actually, data that are measured by sensor and other that are computed by the machine, knowing the context of the usage and so on. For example, for VR headsets, you have usually 3 sensors for the 2 ends, for the controllers, 1 for the head, and you are using invert kinematics to compute the rest of the thing. So each device is able, using our data, there is going the wrong way, is able to stream that structure of skeleton, and the virtual environment is then able to select part of all of the data to define the right avatar for the user. So the idea there is not to provide one generic avatar for any virtual world, because it's not what content creators are expecting. It enables finally the content creator, the creator of the virtual worlds, to put the avatar, the right mesh, on top of the skeleton to match with the global shape of the environment, with the global rendering, which provides liberty to the graphics for sure. And after this, the idea is just to share that joint between the skeleton and the avatar to the user and to the other user, to be able, just by having a continuous flow of data about the movement of the users, to stream the movement of the avatar. And what is the only changes is that we add the possibilities with a specific data model on the server side to complete the animation captured by the device with some contextual animation. So for example, if you grab an object, the virtual world knows where your fingers should go on the object, even if you don't have sensor to track the fingers on the device side. So to be able to complete the animation and to stream it, to broadcast it to all the other users, and to broadcast all the contextual animation to yourself if you want to have a way to see yourself as an avatar also in the VR. Okay, and the last part is about really metaverse stuff, about how users are navigating and browsing in virtual worlds. Because as you know, and it's really the same architecture as big, massively multiplayer online games, virtual worlds are now hosting hundreds or thousands of users, making them distributed on multiple virtual machines, servers, and platforms. And the idea there is also to provide some data models or common interfaces to make users able to travel from between nodes of the same virtual world, but also taking gates, like you are taking links in web pages to go to other worlds. And that's actually something very important for us because for sure we are developing the Interoperable platform as a local platform, implementing this and being accessible by UMI 3D browsers. But anyone taking UMI 3D on GitHub, creating its own platform with UMI 3D, will be able to create gates with worlds created with Inetum solution in Traverse and with others platform implemented with UMI 3D. So for sure, we don't address anything, actually. We don't address Haptic. I know that there is a topic on Haptic just after. We don't address AR at this step because there is other standardization group and working groups on AR and tracking standardization. But this is the four components that are, I think, very different in UMI 3D and that could enter the discussion for standardization in the future. And we are exactly at this step. We will now enter the Metaverse Standards Forum with Inetum at least to explain this, to show what we did, and also to share the lessons we learned during 7 years of research and development. And we will also be looking for partners, new collaborators, especially because UMI 3D is now only implemented with Unity. And for sure, I don't imagine a metaverse where each server and virtual world is created with Unity, but we need to have interoperability with worlds created with different game engine. And also for the browsers, I think we need to have a lot of interoperability on displaying content created with different engines. Okay, I think that's it for me. And if there is any questions.
Thank you, Julien. We have time for 1 or 2 questions. Yes. You have to come closer each time. This is good for me, for healthy, but yeah.
On your avatar, you have no legs. And I was wondering if you could increase the nodes on that at all, or are you going to have like a simplified one and a more complicated one?
I'm not sure I understood you. You mean the number of nodes in the virtual world?
The number of nodes right now do not show any legs, and they do not show a method in which you can increase the spinal nodes as well.
Yeah, sure. The full available list of nodes is coming from a medical reference, meaning it's exhaustive, and each device can declare the list of nodes it is able to compute or to detect. And depending on this, this time the adaptation is need to be done by the virtual world, understanding the list of providing nodes and selecting the one they want to use for animation, the one they don't want to use, and so on. But the idea is to have an exhaustive list of bounds and point of control, and each device is free to declare them or not. And then the environment needs to adapt the avatar animation to the available nodes.
Okay, good. Let's move on. questions can also come later. So let's see if Yeshwant, can you hear me? And can you please try display your screen, share your screen? So the next speaker is introducing the haptics standardization. Let me check if he's sharing. Yeshwant, yeah. No. He will present online. He preferred to present online. So I don't know if Yeshwant, can you hear me? Your microphone is not activated. So you are muted now.
I'm back. Sorry about that.
Great. We can hear you.
Right.
Just try to activate your screen sharing to see if we can have it.
Yes. Let me do that. Okay. Are you able to see my screen?
Yes, we see your screen.
I'm going to go into slideshow mode.
Yeah.
Great. Hi, everyone. My name is Yeshwant Muthusamy. I'm going to be giving a talk on our paper on the overview of haptic standardization. So let's get started. A quick outline. I'm going to go into a quick introduction on the basics of haptics and where all haptics is used in the industry. To talk briefly about why we need to standardize haptics, and then switch gears and go into a short description of the major standardization activities in some of the selected SDOs. So touch is fundamental to how we perceive and understand the world around us. Touch lets you learn about the world through our movement of various parts of our body. It lets you understand the world through our active exploration. It creates a belief in our external reality. Touch enables extended proprioception, which is the force feedback on various parts of your body. And last but not least, touch facilitates effective interactions. And we as human beings take touch so much for granted. So it just makes intuitive sense to complete the immersive media experience and to add haptics into the mix, so to speak. Briefly, there are 4 classes of mechanoreceptors in the human body: Merkel, Ruffini, Pacinian, and Meissner. And here you will see the location of these with respect to the skin. And these receptors, they actually sense the different haptic submodalities like vibrations, surface texture, deformation, and so on, and they work together to provide the nerve pulses to the brain. And based on the actuation type and the type of stimulation which is required, you can see which of these mechanoreceptors are activated. Now, a few words are important here to mention about how haptics differs from the other media types, which are the subject of a lot of standardization activities. Unlike audio, for example, which just requires 2 years, human tactile sensors are distributed over 2 square meters of our skin, and the skin is the largest organ in the human body. And so any kind of perceptual coding for haptics needs to take this into account. One other key point here is the range of frequencies for haptics is quite different. Quite different than what we are used for high definition audio and video. It is only about between 0 and 800 hertz, and 5 hertz and below is particularly significant for force feedback. So some points worth keeping in mind. So if you have a smartphone and if you are using it on a daily basis, you are interacting with haptics on a daily basis. Both Android and iOS have pretty advanced haptic APIs, but they are mutually incompatible with each other. When you go into gaming, the Sony PS5 DualSense controller is currently the gold standard for haptics. It has got 2 vibrotactile and 2 kinesthetic actuators, and it's quite fun to use, but it is also using a proprietary effect encoding. And when you go into the XR space, you have a number of pretty advanced offerings, or increasingly advanced offerings, I should say, from HTC Vive, the new MetaQuest Pro, and so on. But there's really no standardized effect encoding currently in use. And this seems to be a theme that you see across the CE space. Once you, when you go into the automotive space, you're seeing an increasing move away from mechanical buttons on the dashboards into screens. This is an example of a late model vehicle with a 56-inch hyperscreen, which is actually being driven by 3 haptic actuators, and the user experience is quite something. And from the point of view of the BOM, or the bill of materials, auto OEMs are actually finding that moving to haptic touchscreens is quite cost efficient. In the consumer VR space, we are seeing a move away from the basic kinds of actuators to more advanced high definition actuators. And you are also seeing the advent of haptic bodysuits, often with up to 24 haptic actuators in various parts of the body, mainly used for gaming. And the team that utilize all of these advanced CE devices is that the manufacturers are building walled gardens. They all have proprietary APIs, incompatible hardware to software interfaces. The vibration motor characteristics are different, and this de-incentivizes content creators and application developers to include haptics in any meaningful way, because any changes to the lower levels of the stack are going to affect your software and your middleware and your application layers. And what it does is the end users are not quite fully on board, because they are the ones who are paying for these devices, and the fragmentation doesn't quite help there. If you move to a more standardized approach, you're going to be able to harmonize the offerings from the vendors without compromising any kind of the vendor differentiation, because all you're doing is providing a standardized interface, but the implementation of the interface still gives you a lot of options for vendor differentiation. And of course, this leads to more content creators and application developers wanting to include haptics, because you're able to leverage the standardized interfaces. And of course, and the walled gardens give way to a more flourishing haptic ecosystem. So I'd like to switch gears now and move on to talking about some key organizations. The first one that comes to mind is the Haptics Industry Forum. This is not an SDO per se, but rather a consortium of like-minded organizations, both from industry and academia, who would like to come together in an IP-free zone to talk about the issues and the challenges that face haptics, and how we can improve the standardization of key aspects of the haptic stack. And it was founded way back in April of 2020 2020, and it has grown since then. We have about 29 industry members from the various parts of the stack, so to speak. You have actuator manufacturers, driver AC manufacturers, driver IC manufacturers rather, middleware and API developers, as well as content creators. And so it's a pretty good mix. We are agnostic of the platforms. Our main goal is to make sure that haptics works on all platforms. And we have some reasonable output in the short time that we have been in existence. We have 5 published RPs, and we also have a number of working groups like in XR, gaming, and automotive, and so on. So if you're interested, please feel free to join. Moving on to MPEG, the Motion Picture Experts Group, and MPEG is one of the most influential international standards organizations. MPEG is the one that gave you MP3, AAC, H.265, and so on and so forth. And we are glad to report that haptics is now part of the MPEG roadmap. And so our approach as far as haptics in MPEG has been a 3-pronged one, and I'm going to briefly hit upon each of these prongs. The first one is we wanted to make sure that haptics could be established as a first-order media track along with audio and video in all ISO media files, and we have been able to do that. The latest version of the ISO BMFF standard, which was published earlier this year, actually has haptic tracks. The next step, which is ongoing, is to flesh out the lower level haptic codec specific boxes in ISO BMFF. The next step, which is also about to start, is to make use of the ISO BMFF standard to see how you can incorporate haptics in media streaming. And once you are able to do that, all of the major streaming services will be able to incorporate haptics in their content in a standardized way. And so if you're enjoying your favorite streaming content on your handheld device, haptics will be able to complete the immersive experience, so to speak. Sorry about that. Let me go back. Yeah. And last but not least is the MPEG-I, where the I stands for immersive media. And this, of course, is of quite a bit of relevance to this audience: AR, VR, XR, and gaming. And here we have a 3-phase approach. We have to walk before we can run, so to speak. So our phase 1 is where we are developing a basic haptic coding format and standard, and it has just gone into ballot. Is someone trying to say something? I hear some background noise. Okay.
From our side, no.
Okay, I'll keep going. Then next stage, which is phase 2A, it adds support for spatial haptics and scene description. We hope to be able to issue a call for proposals sometime next year. And the last phase, which is the fun part, is to add support for interactivity and avatars and XR experiences of the type you would find in the growing metaverse. And that's further down the line. The key point here is each phase builds upon the technologies which have been standardized in the previous phase. So we are not starting from scratch. And so a few examples of the phase 1 use cases, the kinds of use cases we are addressing in phase 1. All of these are quite familiar with the only point here is that instead of just audio and video, now you've added haptics into the mix. For phase 2A, we take it up a notch in the sense that your haptic perception is going to be very much dependent upon where you are in the scene or which of these players you want to be viewing the scene as, or also the location of you with respect to the action in the scene is going to determine to a large part your how you feel the haptics. And you also have the D-box like immersive home theater, where you have haptic actuators in the chair, and it increases your enjoyment of the content that you're watching. Phase 2B is where things get real, so to speak. We will have a lot more advanced use cases, tactile e-commerce, for example, where you should be able to quote unquote feel the fabric before you're able to make your online purchase. Long distance surgery, where precision and latency become quite important. Virtual hand-based immersive VR, telerobotics with feedback, training, and simulation, and interactive with video calling are just a few of the approved use cases which we are planning to address as we go along this MPEG phase 2 for haptics, phase 2B rather. Moving on to Khronos, and Neil has already briefly mentioned the OpenXR application interface, which provides a cross-platform high-performance API between the game engines and XR applications and the devices. But the fact of the matter here is the existing haptics functionality for OpenXR is quite basic, and we would like to change that. So we would like to provide or propose a number of advanced haptic extensions to OpenXR that would actually bring a lot more haptic functionality to the game engines. Well, and our strategy here has been to basically take advantage of the XR expertise in the Haptics Industry Forum XR working group to develop an extension and to propose this extension to OpenXR, and that process has already taken flight, and we are in the midst of doing that. In the interest of time, I'm not going to go into too much detail about these two haptic standardization activities in IEEE, except to say that they are almost done standardizing a vibrotactile codec and two kinesthetic codecs, but these two codecs are not quite suitable for the types of the MPEG-I use cases, which is why we embarked on the MPEG-I haptics project in the first place. The second effort, the IEEE P2861.3, takes a slightly different approach. It's haptics interface enhancement for mobile gaming, and a number of mobile OEMs are quite active in this space. And the idea here is once IEEE P2861.3 is done, it will be able to provide a standardized interfaces that allows gaming content to be played on multiple mobile platforms. It's worth briefly talking about haptics in the next generation broadcaster standard called ATSC 3.0. A number of stations in the US and in South Korea are actually have already begun to broadcast in ATSC 3.0. And one of the big promises of ATSC 3.0 is the ability to watch TV on any device and in any location. And they have this notion of a primary device which receives a broadcast, and it uses a wireless protocol to transmit that same content with some enhanced features to your companion devices. Now, in a perfect world, the haptics stream the haptics track would already be part of the broadcast stream, and you would be done. but since we are not quite there yet, haptics in these transport protocols is not quite standardized yet. The lower hanging fruit would be to have content specific haptics to be synced to the ATSC broadcast stream and then played on the companion devices. And the step-by-step process or the recipe for doing that is what is the subject of the recommended practice on haptics for ATSC 3.0, and this has been approved and released early last year. And the last SDO that I want to talk about is our efforts in IETF. As you know, the IETF is the open internet standards body that's responsible for many of the foundational standards which we use on a daily basis but kind of take for granted, like HTTP, email, and RTP, and so on. And they have a number of top-level media types already. What we are trying to do is to propose haptics as a new top-level media type. It was first introduced at IETF 109, and it has since progressed to a proposed standard. And we hope that it will get approved as a standards track RFC. Why is this important? Why should we care? Because an IETF haptics RFC will be a foundational enabling standard, and it will also enable the proliferation of haptics media in a standardized manner in all internet media and communications. And once you have haptics as a top level type, it will open the door to for IANA the registration of multiple haptic subtypes under this top level type. And I have listed only a few of the examples of the types of subtypes that can get edited. And this will also help our ongoing standardization activities as well. So we are looking forward to this being a new RFC. And with that, I'm going to stop here and ask if there are any questions.
Okay, thank you, Yeshwant. Let's hear from some questions from the, someone that would like to go into the haptics domain. We have a question by Don in the chat window.
Okay.
No, that was for H&M. I suppose that was for the previous presentation. Yes, we have one question by Nicholas.
Thank you for your presentation. I'm curious, so you're speaking to a graphics community here. I wonder if you could help us understand some of the different requirements in haptics. For example, the update rate that is sort of required to make a convincing haptic experience. Is it faster than visual, slower? What sort of regime is this living in? Thank you.
Sure, that is a very good question. It depends on the use case. I mean, it depends on whether you want the haptics feedback to be complementary to the audio and visual latency, or whether haptics is going to take precedence in your use case. I mean, the haptics latency, which we are trying to, the haptics latency requirement is 1 millisecond. And but in terms of where you want the haptics to fall, it really is a function of the use case. I mean, in many of the use cases, haptics might be something which comes just a few milliseconds after the audio and visual part. But in other use cases, haptics is front and center. I hope that answers the question.
Yeah, another question by Indira.
Thank you so much for your presentation. I've been working on haptics, and I'm so happy to see that things are changing now, because it was impossible to have such a development of haptics 20 years ago. And as an old professor in this field, I know that there is a problem of interpretation, because when you have haptics perceptions, then you have equipotentiality of what you feel. And this equipotentiality is disambiguized. Well, there is an ambiguity, and with the multimodality like visual and maybe sound, it is possible to understand the perception. But what about this problem that we know very well in haptics?
So your question was, how do you make sure that the haptics perception doesn't get lost, or is it be able to disambiguate it?
I mean that when you get a display, a haptic display, it can be interpreted by the human being in different ways. And it is very difficult to understand the haptic signal and the haptic display, even if it is a very specific situation. So that's a point that I wanted to ask for information if you have ideas about it.
That I think seems like more of a MPEG phase 2B requirement. And we are still in MPEG phase 1, where we have gotten done with this notion of timed haptics, where it's synchronized with audio and video, and we have a coding format. What you are referring to is more of the haptics interactivity, and that is a problem which I think we are going to have to come face to face in the MPEG phase 2B. So right now I have some thoughts on it, but I don't think our thinking has evolved to the point as to how we are going to address that issue, because we are about one phase away from being able to tackle those kinds of requirements. But I see a point. I mean, this is going to become an issue when we are dealing with the requirements pertaining to interactivity in the MPEG phase 2B standardization effort.
Thank you.
Okay, thank you very much. Thank you, Yeshwant. I think we have to move on.
Sure.
Yeah, no other questions. Great. Okay, so just a short announcement for people that get connected for the panel. So we will have a short delay in the panel because we had some delay when we start the session, but don't disconnect. Stay here and listen us. So let's go for the last presentation of this first part of the workshop. And by the way, that is done by me. So I will try to be fast. Okay, you see my screen, and I think the others can hear me. Okay, well, I don't have to introduce myself because you already know me, but as you may imagine, I am not doing Web3D program chair as a daily basis. I also have some other life, and one of these aspects of my other life is I'm the convener of ISO MPEG 3D graphics and haptics. And what I would like here to show you is our roadmap and what we achieved in terms of 3D graphics coding, and why we believe that coding itself, so when I'm saying coding, I'm talking about compression, is something that we have to look very carefully in Metaverse. And by the way, you are here in a telecommunications school, so you may not imagine our engineers to transfer data without compressing, of course, without losing the information, but that is key. Okay, so I will go fast. The slides will be made available, and if you have questions for details, you know how to find me. So some slides, I will just go through them quickly. First, what is this group with a long name, WG7 in ISO, IAC, and so on and so on? on graphics and haptics coding, and why we believe that the activity in this group is relevant for Metaverse. First of all, we are an ISO group. You know, ISO is doing standards for everything, including the dimensions of the chairs that you are sitting on, but also information technology. And SC29 is a subcommittee in ISO that is addressing multimedia coding in the sense of compression. We have SC24 that is more doing graphics representation. So the compression is the keyword. And there are several important aspects behind that. The compression layer is application agnostic, or at least it should be as possible application agnostic as possible. In the same time, we know already that in the 3D graphics domain, we have a lot of variety in the raw data representation. It depends a lot about how we are using that data for what kind of applications and for what kind of usages. And traditionally, we applied compression in the signal processing manner for the ones who remember what you did in the school: prediction, quantization, entropy, coding, and so on. And more recently, we are also looking to data-driven models, which are the AI-based approaches. Okay, Neil mentioned before glTF as the candidate for JPEG of 3D graphics. That is good. Is already a good base. Of course, on top of that, we have to have compression. Otherwise, it will not be the equivalent of JPEG. But like he also mentioned, 3D graphics should be treated in the same way as audio and video and images. It is not enough only to represent it, but we also have to encode it to be able that would be efficiently transmitted. There are some problems. The reason why we don't have yet this JPEG of 3D graphics is not because the theory is not there, but there are a lot of problems. And one of the problem is to answer the question, shall we represent the mathematical representation of that content or the output directly? So either, because we can have a parameterization of the 3D graphics is a parameterization by itself, but you can have different levels of parameterization up to the pixels that are rendered. And knowing where to stop in this chain, it means it gives another representation. So it means it gives some other constraints on the data from the point of view of the compression. So there are some difficulties in terms of variety of the model and variety of the data itself, because 3D graphic is not only one kind of data, but we have geometry, attributes, animations, lighting, and so on and so on. Okay, these are the slides where I will go fast. This is the history of what MPEG did in terms of 3D graphics for years now, starting with 97. 97 is a good date in our community because is when VRML become an ISO standard. And even if it's not used anymore today or partially used, it allows us to learn a lot about how to do standard for graphics. So 1 year later, MPEG took VRML and add compression on top of that. What it is absolutely needed to be compressed in 3D graphics is the geometry, the mesh at that time, point cloud later on, textures, videos, of course, and the animation. So this is what was done in 98 and 99. And you have here examples, I will not play with them, avatars. So this is an example that we did even here at school, the first augmented broadcast television, 98, last century. Still augmented reality on television. Okay, we've moved on, and we address this variety of representations by creating coding schemes, compression schemes for all kind of data. Of course, triangles, meshes, animations. You have here an example of terrain rendering. The terrain guy from yesterday, maybe he's online. So what is the problem with the terrain rendering is that there are so many meshes that you cannot display them at once and you cannot transmit them at once. So what you have to do from coding point of view, you have to transmit them progressively. So depending where the camera is, the data is transmitted by the server progressively. And that is something that existed even 15 years ago. Another example with the city. Here again, we are walking through the city and the data is transmitted by the server depending where the camera is. Okay. Some other developments in terms of graphics, coding, and the compatibility with the browsers that appear in different versions of the standard. And here is the list of the codecs that were defined for different shapes, for different textures, and for different animations. All this is history. You can find that. Then another track was the development of sensors for multimedia experience. Yeshwant mentioned about having, together with audio and video experience, to have haptics. But we can have much more than only audio, video, and haptics. We can have the 3D environment. So for that, we need to sense that environment and to actuate on the environment. And this is another line of standard developed by MPEG that is called MPEG-V with data format definition for sensors and actuators. What was also a part of MPEG-V, that is the architecture, of course, I will not explain it, but what was also a part of the MPEG-V, so this is 12 years old, more or less, 15 years old, more or less at the time of Second Life. And one of the requirements at that time was to be able to take an object from one virtual world and put it into another virtual world. Of course, it was not called Metaverse at that time, but don't have the feeling that we are inventing now something new. This is something that existed for, Nicholas mentioned yesterday, 97. Blackstone community was one of the first where people could join a 3D place on the web and have actions with avatars and communicate with the others. So in this part of MPEG-V, the idea was how I can put my avatar that I can create in a virtual world into another virtual world. And there are a lot of parameters that can be standardized that makes this conversion or transfer doable. Okay, later on, we produced also on something that we call ARAF, which is a formalism for representing AR experiences based on what MPEG-V did and the compression part did. And so I move now in the compression side. One important aspect is that in graphics, for a long time, we didn't need particular compression because people only use zip or any kind of generic compression, and that was good enough. Was good enough because the assets were not so dense, because the assets were produced manually in authoring tools. So we put a new wall and a new wall and some texture on top of it. By design, it is not dense. But if we are now considering that these assets are not created by artists, but captured from the reality, they become very dense. Okay, so going fast, we have this path of what happened in the capture world. We have better cameras with higher resolution. The range of the colors is deeper. Multi-rig cameras. We are able today to extract the information from the real world. And on the other side, so if we want to represent this part, we can use either video, stereoscopic video, or video plus depth, or many video and many depths. But we can also use a reconstruction algorithm and create a point cloud. We already saw during the conference different solutions for how to create from images colored points, which are nothing more, nothing less than 3D pixels with color. But we can also produce meshes. It is not easy to take from the point cloud to produce meshes, at least automatically, but it's something that can be done. Okay, so some years ago, we start to look carefully on this representation mode point clouds that were the result of reconstructions, and we try to set up some technology and eventually have the standards for compressing this representation. Going quickly, a point cloud is a set of 3D points, the same as you have in images, which are 2D points. Here we are talking about 3D points. There is a huge difference. In the image, there is a relationship. We know that I plus +1 pixel is a neighbor of I. In 3D, we don't have that. Each point is defined by the position, X, Y, Z, and some attributes can be the color, but can also be something else like reflectance or any kind of other attributes that are helpful for graphics rendering. Here is an example. Some of you already know this example. Is of course, you see it as a video, but it's a 3D point cloud captured with 40 cameras and reconstructed, not on in real time, of course, but it gives quite good quality on, yeah, is through Teams, so you cannot see it fluidly, but is a quite good quality of reconstruction. Other examples, also relatively well known, the one of Microsoft with HoloLens. When they launch HoloLens, they produce this demonstration where you can see through HoloLens soccer gamers, soccer players, small ones, and also the other one from Intel where you see the basketball player, and at a certain moment that camera can turn around because it's a 3D representation of that player. So the applications are there. The problem is that without compression, this kind of data for one single person is about 1 to 3 gigabits per second. So not useful at all. Even if you want to read it locally, it will not be possible. Yeah, some other examples that we created here. I think they are still in the room, the students, with an AR device. So we have this guy looking at the scene, and of course he can see the other, which is a real one, and this one is a virtual one. Okay. Other example, even going further and with implications that are going much more deep in the change of our society, are the point clouds that are produced by the cars. So assistant driving or even autonomous driving are actually even today using this kind of format. But here again, without compression, not useful. Okay, just to keep in mind some numbers. For this kind of object, you may need about, let's say, 1 million of points. And if it is not compressed, it's about 1 gigabit per second. Okay, so this is the starting point. Okay, after doing the entire process, and maybe we will discuss later on about the process in standardization, the entire process of call for technologies, competition, which technologies is better, and then some collaboration to try to make the standard. We end up with 2 standards that were published this year, video-based point cloud compression and geometry-based point cloud compression. Mainly because even in the point cloud world, there is heterogeneity. Some of them are dense, some others are not dense, and you will not treat them the same in terms of compression. Okay, so the principle of the first standard, video-based point cloud compression, is relatively simple. Instead of having a 3D representation of an object, we will project that object on different planes, and we encode the planes by video coding. As simple as it is. Every 3D representation can be projected on a number of planes, such as a reconstruction will be easy and possible. Okay, so this is done in the standard. It goes with a lot of details. It goes with the colors and the geometry, and what you would like to know is what we have at the end. So an object like that will be represented with 3 video planes, one representing the color, another representing the distance with respect to the projection plane, and another an occupancy map. And since all of them are videos, we encode them by any video codec, MPEG is very good in video coding, so the problem we can say that is solved. Of course, it's not fully solved because this is not what the video encoders like. In general, you have much more redundancy. But there are other things that on top of the standard that can solve this problem. Okay, and what is important are these numbers. So you remember the number about 1 gigabit, 123. So by compressing, we can reach bit rates between 5 and 7 megabits per second, which is huge. The ratio is relatively huge. But also it means that local current networks can handle this. And the difference with respect to what we saw these days when we are talking about avatars, these look very real. So if we want to have realistic representation of metaverse one day, for sure we need to use this kind of compression tools. Okay, the software is available, a lot of information is already there, the standard is quite advanced now. Okay, I will go through this one and just give an indication about what is next. It's always like the same. Next is looking in the past. So since we have a good method, video-based method compression for point cloud, we want to do the same for the meshes. Of course, the meshes that are captured from real. Why meshes are nicer? Because we did everything in the past to have them nicer. It's more compact, first of all. Then the graphic hardware, the current graphic hardware is optimized for meshes, not for points. And also the operations are much easier to do on top of meshes because of this neighborhood information that is encoded in the mesh. So we did the same for that, and we start recently, was last year, a new standard on coding dynamic meshes with the same idea that the mesh is projected in 2D planes, and then the video codec will be used for that. Okay, I will stop here because I don't want to go too much in the panel discussion, and I conclude that we in the 3D graphics group, we developed in the last decades compression technologies for 3D graphics. We are agnostic with respect to the format itself. So it can be glTF, it can be X3D, it can be Collada, it can be anything that is already in the pipeline, with the idea of having a solution that allows to transfer this data and on the other side to decode. And we see the compression layer as one of the solution for the interoperability. So because the compression requires some hardware acceleration for coding and decoding, we may have this layer of coding together with some light data representation that can be format specific or application specific, doesn't require to do it in hardware, it can be done in soft. And of course, this should be done and can be done with collaboration with other SDOs, including X3D, he's here, glTF and Khronos we already heard about, and other people that are interested in that. Goodie, I'm done here. So if you have questions, I can take some questions. If you don't, you can keep them for the panel discussion. I hope that I didn't scared you. Okay, let me see the panel discussion, and let me see if we have everybody here. Okay, so we have Chris. Can you enable Chris? Okay, and then I see Ingo as well. I see Mark. Great. Who else? Ralph, of course. Ralph, you are physically here, so please come. Nicholas, you are also invited. Don is also connected. Good. So The panelists let just us install the 3 chairs here, and we will start. We have 2 microphones. Okay, I also see Yeshwant is connected. Yeah, Yeshwant is also connected. Okay, before starting, let's just make a quick check with all the speakers to see that your microphone is we can hear. So Chris.
Yes, I'm here.
Great, we can hear you. Mark. Mark, can you activate your microphone? We can see you, but not yet hear you.
Now you can.
Yeah, good, great. Nicolas is with us. Julien.
Hi, good afternoon.
Great, good. Okay, I also saw Ingo. You have to press your, yeah.
No. Oh, yeah, now I can, now I can. It showed only organizers can activate the microphone, but it just got activated, so great. Good afternoon.
Great, and then who is missing? We have Don. Yeah, Don, can you activate your microphone? Oh, you also have to add Don because, yeah, just wait 2 seconds. Is Don Brutzman? Yeah. Okay, Don.
Hello.
Great, we can hear you. Okay, and we still are waiting for Leonardo. I think that he is not yet connected, but when he will connect, you should access it. Okay, good. Okay, let's start our panel discussion. Is about standards, and we try to have here people from different standards organizations. Because we know that, as I mentioned, we have a lot of standards, and since this metaverse is going transversal through our society, it is almost obvious that not only one single technical aspect should be covered, but plenty of them. So we have here Don, Leonardo, Chris, Mark, Nicolas, Ralph, Ingo, and Julien. You have their pictures displayed here. You don't have mine because you already know me. So I will start by asking them to introduce themselves, just to say a few words, and then we will go with some prepared questions. I only have 3 general questions, and of course the goal is also to have a discussion with the room, and then let people interact with the panelists. So let's start with Don.
Hello, everyone. Don Brutzman. I am calling in from Monterey, California, and wishing I was in Paris, but very happy to be here. I am the co-chair for the X3D Graphics Working Group.
Great, thank you, Don. Is Leonardo online? Not yet. Okay, let's move to Chris.
Hi, I'm Chris Lane. I'm co-founder and CEO of 3DMD. We've been working on high-resolution models for the last 25 years. And the importance of standards is brought on by the fact that we implemented internally a temporary standard back in 1999, which regrettably still 25% of our customers use. So we've got a big challenge ahead with the metaverse to try and get these standards built in from the outset.
Okay, thank you, Chris. Mark, yeah, we had Mark this morning, but it's good to speak again, Mark, because not everybody was connected this morning. Yeah.
So, hey, I'm Mark. I'm the VP of the Unreal Engine ecosystem at Epic Games, and not member of any standard defining organization, but with a keen interest in open standards.
Good, good. This is why we bring you here, because we want to force you to be a member of any. You choose. Okay. Nicholas.
Okay, thank you. Nicholas Paulus, Director of Visual Computing at Virginia Tech. I'm also the elected president of the Web3D Consortium.
Okay.
Thank you.
Ralph. Press the button. There is a button.
Hello, yeah, works. Hello, I'm Ralph Schäfer from Interdigital. I'm VP Standards there. So my work is 100% related to standards. So I participate in MPEG, work together with Marius since a few years. Besides that, I contribute to ATSC, DVB, SPDVD Brazil, in fact, so all the application standards organizations, 3GPP. That means we try also to get what is developed, in fact, from the core standards to applications, to mobile devices, to TV sets, and I will try to get that aspect a little bit here to the meeting. Thank you.
Thank you, Ralph. Ingo.
Hey, good afternoon. Ingo Simonis. I'm Chief Technology Innovation Officer at the Open Geospatial Consortium. And Mark, Epic Games is a member of the OGC, so you are indirectly at least part of a standardization organization. So OGC is all about location, right? It's on the one side, it's a standardization organization. On the other side, it is a community that deals with all elements of location. So how to identify it, how to detect it, how to communicate it, how to express it within real and virtual environments.
Great, thank you, Ingo. And Julien?
Hi, everyone. I'm Yeshwant. I'm the president-elect of the IEEE Standards Association.
Great. Thank you for that. So we have a lot of SDOs. I don't know if there is, yeah, there are some of them that are not yet here, but still, ISO, IEEE, OGC, Web3D, Khronos was before. So I think we have a good set of representatives, and we may have something to say in the domain of standards for Metaverse. So I prepared a few questions, and yeah. I will let you answer in the way that you would like. But the first one came in my mind was, what do you consider to be the most important aspects in Metaverse or for Metaverse today and in the next decade? Of course, we are here. I'm here referring to the characteristics of Metaverse, like 3D, because this is why we are here. Real time. Realistness versus artificial kind of content, and so on and so on. But of course, you may have other views. So if you don't mind, I would like to keep the same order. So Don, can you try to give us your feeling about this? What is?
Sure. Can I share a slide?
Yes, sure.
Okay. I've got a slide, I've got a button. And how's that, I hope? Is that coming across?
Yes.
Okay, here's my one simple slide to answer every possible question. We think they're all important. X3D Graphics is part of a Web3D consortium. We've been doing this since our first Birds of a Feather at SIGGRAPH was in '94. We've been doing it with Verbal 97, on and on. We like working with all the other standards. We're focused on our stuff first. It's in the final stages at DIS, Draft International Standard at ISO, and we think it'll tip over pretty quickly right after that. Version 4.0 is actually our 8th version, if you count Vermal 1.0 and going with each incremental thing. So forwards and backwards capabilities are very real to us, and we don't accept anything until we know how to go forward from there so we don't break it. I'll save the second half of my slides for the second question. Thank you.
Okay, let's move on, and then we have Leonardo, who is not yet here. Chris.
Sure. So I think the biggest challenge we have with the metaverse is understanding the scale of what we're embarking on here. I think if we look at the noise which Meta has been getting from the investment market at the moment, who seem to think this is some sort of glorified multiplayer games environment, it's not. It's fundamental to the future of the planet, and it brings together so many disciplines. Certainly, the web in its current form is unsustainable from a security point of view. We've got to get more personification in that and verification. But also, I think the metaverse is the key to the Internet of Things. We don't seem to be mentioning that quite as much recently as we should do. But I think with the metaverse, things like electric cars are not going to be practical because they don't understand people. And that is the issue we've got going forward. The metaverse is absolutely pointless without people. It's a ghost town. I remember giving a lecture in Moscow in 2000 about the ghost town called cyberspace, which was our old name for it. And I think if we don't understand how we're going to get people in there, not in some cartoonized, stylized form, but as replications and almost seamless replications of those individuals, the metaverse will fail because it won't provide the humanization that we're expecting from it.
Clear. People in front. Good. Mark.
Well, I'm going to repeat some of the things I said this morning because we are this afternoon and not this morning anymore. But so you asked both long-term and short-term. I think the short-term challenge is to start enabling a basic level of interoperability around scene composability, scene layering, and bringing those capabilities so that we have a foundation to build across, with the ability to have content of a complexity that is acceptable by people and that unifies across all forms of media. So we have to support film grade quality and a level of visual fidelity that is very, very high. I think it's a short-term challenge. And the longer-term challenge for me is all about, and again, I touched on this morning, is making the metaverse, something that augments social interaction, and that's co-presence and co-participation. But co-presence and figuring out solutions so that we can feel like we are with people when we're online would be a great 10-year decade objective from my perspective.
Okay. Social aspects. Yeah, Nicolas.
Thanks. Yeah, so I was really pleased and hopeful in a very good way about sort of some themes that were common to our keynotes. I certainly believe that the people and the sovereignty of cyber citizens is central to this. This is a hard problem, as we know, and maybe as technologists, we can advocate for things, we can make consortiums and do some lobbying. I think all of this is necessary. But I also think there's something that's also sort of hasn't been mentioned explicitly yet. It was a bit about the creator economy, as we heard this morning. But that's really why people use standards in the first place, right? Is building this stuff is expensive. And if you, if you have some facilities that might last 60 years, 100 years, a building and so on, you can't give this data to a Silicon Valley company, right? You need to be able to access it and know you can access it in the years to come. And I think that's a little bit of, I have to say, a luxury of my position as an academic. That's the first thing we do, right, is to make sure that the data is reproducible. And over the last 24 years, and you are welcome to bring up any of the applications and use cases that we've done, we've taken something like X3D and extended it, continue to extend it, and all this old stuff still runs. So there was a comment about persistence. yes, in that it's online and it's still there if I go to sleep. That's one kind of persistence. But actually the content that's there needs to be owned by the creator, and also that they can have confidence to use it in lots of different vertical areas, lots of different activities of their life. Because I think the metaverse does have this potential, maybe to fuse this fragmented physical and digital life that we have now. So I would put reproducibility centrally, in my opinion. Thanks.
Good, thank you, Nicholas. Ralph.
Yeah, I think the use case of capturing real world people, not just in 2D, what we did to do today, but really in 3D in a volumetric manner, and transport it, compress it, transport and render it on the other side. This is a very important use case. So it is what we, Teams or whatever, WebEx, Zoom, 3D, this is interesting to do. What many people do today on a mobile phone, just capture videos, publish them. This could be done in 3D, right? And there were already smartphones available. There was, for example, a Nokia smartphone with 7 cameras, so 6 cameras in a circle and 1 in the middle, and it was able already to capture some volumetric video. So this is coming, right? But also better quality content is captured in a more professional rig. It can be produced to something, that is really exciting in the end. So I think this is really important. And here we need really what Marius has shown in his presentation. We need really efficient compression standards. And that, of course, we have better and better networks. So the internet bandwidth is getting better and better. But volumetric content, it needs a lot of bandwidth. And of course, this all needs to be in a scene, what Mark said around scene description. I think this is important. So compression, file formats, streaming formats, scene description, in fact, putting this also into a sort of web application. I think this is really what is needed for standards. Just to give a little bit information on the analogy from 2D video today. Today, more than 80% of the internet traffic is video today. It's 2D video. This is enormous, in fact. So if 3D video or volumetric video gets just a little bit of it, this will be enormous, in fact. So I think really that the compression and the related standards around that, they are key. Point clouds, meshes, in fact, but I think we come back later to that. All this is key. Of course, it needs to be accompanied by the other aspects that have been described before. But I think it is an important part. Thank you.
Okay, thank you, Ralph. Ingo, do you think that we'll have latitude and longitude in Metaverse?
Well, the Metaverse gets certainly more exciting the more real it appears, right? Once you are part or in the Metaverse. So we need to understand the role of location, and it is pretty important. But if I look at what's really important, and if I look at other developments that we have seen over the last couple of years, and one good example is, I think, augmented reality, which has never really got off the ground on the mass level. Yes, we do have applications more in the professional space, but why hasn't it, right? And I think elements like sovereignty, what do I do with my data? What happens with my data? If we don't get these under control, then we can develop as many standards as we like for technical challenges, like compression, for example. We can have as many standards for getting a ton of sensor real-time data in. That's all great. But if people have the impression that with their digital representation, others can do whatever they like, then nobody will join. That is human behavior that we have seen in the past with Google Glasses, right? And people being beaten up. So why shouldn't the same thing happen with the metaverse? I think these more social questions need to be in focus for the next couple of years. And well, let's see how much of the metaverse we can build, right? Maybe we end up with very targeted individual metaverses and not with the thing we dream of that is really a full kind of three-dimensional or four-dimensional representation. Because once I'm in there, what prevents me from jumping back and forth in time? What prevents me from going through walls and basically being a beam from one location on the planet to another, right? Nothing. And but I think the social aspects and the privacy and the sovereignty aspects, these need to be addressed, well, at least as a very high priority.
Great, thank you, Ingo. You.
Yes, so I think first of all, we need to at least have some very basic agreement or consensus on what is the metaverse, the definition of metaverse. Some people may feel that we probably don't have to define that until we have reached to a more mature level, but you probably know that people from the crypto community, many of them are saying that the metaverse is like a decentralized internet based on blockchain. I believe most of the people in this room will not agree with that. Then what's our opinion? What's our definition of metaverse? We should have at least have some kind of definition for that. And also we need to distinguish well, different features of metaverse, like what makes a metaverse different from the traditional VR experience. So what are the mandatory features of metaverse? What are recommended features and what are optional features? For example, decentralization, I think that's probably an optional one, but persistent, that probably, in my humble opinion, would be a very key feature. And on top of that, we probably also need to address some ethical considerations so we can pave the way for the industry before, things get too complicated. I stop here and thank you.
Yeah, thank you. Yeah, I have the feeling that there is a common expression of saying that technically we can do many things, and we already did a lot of things, but without completing that with some social related aspects, some regulations, some rights, some people that are not in our community by default, but either we should bring them in this kind of technical communities where either it's our role to go and talk to them and tell them that something huge is happening. Okay.
May I respond really quick? Thanks. I really appreciate Yu's point. We tried to, we did a little thought experiment yesterday in the keynote to have people imagine the metaverse, and we started to inquire about what properties does it actually have. I couldn't agree more. We know about successful processes in human-centered design and software development, right? And it is about building requirements. And if we're going into this dark night without any requirements, I don't see any hope of success. So thank you, Yu.
Okay, if you want to add something, don't hesitate to add things. Okay. Good. Let's move on. I have now a more provocative questions to Mark, and actually is not only to Mark but to everybody. But let me say that I think I know the answer from the others. So my second question would be, is now the right time to address interoperability in metaverse, or shall we let first the industry compete, because this is what they like to do, fight each other, kill each other, lose a lot of money, and eventually, when everything will be almost lost, to try to do the standards then? Who wants to start?
Do you want me to start?
Yes, please.
Well, it's a question, because of my association with the Metaverse Standards Forum, the question why now came quite a bit. And I think, I said, we don't know where this is going, but for me, a good standard is something that's widely adopted. I mean, adoption is a measure of success for a standard. And I think when the reflection that we had came from, we were seeing things being widely used and going into different direction. And our goal was to synchronize the roadmap of those things that were currently used. And that's why we use terms like minimally prescriptive. We're not trying to, impair any kind of innovation or competition that's good. But at the same time, there are things that there are very basic things like scene layering and compositing that we know, like HTML. It started with hypertext and a structure when you can bring all kind of images, all kind of text, and all kind of elements together. And I think if we show some restraints on the standardization and are kind of in tune with the needs of the industry, we can, kind of provide those shared components so that we actually can accelerate, the competition. Because for me, the standardization is a vector of commoditization, and you need to be mindful, and you need to be, to understand the parts that are ready to be commoditized. And the commoditization for me is not something people want to compete upon. I mean, the way you lay out objects in a scene and being able to exchange a static scene is not something that is going to be a competitive separation for any 3D. I think it's time to anchor this one. Now, we never talked about physics. We never talked about behaviors, because we think that's a space where the competition needs to play out. We haven't seen something that has momentum. We all live with the same world of physics, but yet we haven't seen a physics solver that can solve everybody's problem. And so I think it's an exercise in judgment, and we know that's one of the least. Judgment is something that's different for everybody, and we need to give it a go. So it's actually walking that fine line about understanding when a certain kind of capabilities is ready to be shared across industries and competitors.
Yeah. Thank you, Mark. It's good that you mentioned HTML, because I remember when I was young, there was something around called Adobe Flash. And I hope no one worked for Adobe Flash at that time from this community, because that made us lose 10 years in humanity development of the web. And it's good. Eventually it ended. And because HTML, JavaScript, CSS was much more open. But still, we lost years in web development because of that strategy of putting everything on top of something that was not open. So I don't want to take.
I'll take another example along those lines. I mean, you remember the beginning of video on the internet when we had browser plugins to implement codecs. That was not good from a usability perspective, but it helped, things shake down, and it helps in video internet, compete and develop. And ultimately, video became commoditized and standardized. But at the beginning, there were browser plugins. I mean, I see we should have structure that allows for that for the beginning. So, so that we can have experiment with different technologies and allow vendors and people to compete and at their own pace. So I think, it's the standardization is the art of timing in my mind.
Exactly. This is also the question. Is now the right time, or we should wait? Let's hear also from others
Sure.
Who wants to. Okay, let's take Don. Let's start with Don, because I see him.
Okay.
First
Merci. I was going to put the slide up, but let me just go around the Hollywood squares here first. We like all the standards, and for almost 3 decades now, we have not waited for industry, but we've listened to industry. We said, how does this work? Is it stable yet? Can we work with standards? We've got a liaison partnership with OGC. We've been paying attention. We've got geospatial X3D available and people using it. The Navy has a collaborative virtual environment that can do it. Chris Lane, his team is unbelievably good at human body. We know what the requirements are. We've implemented many of them. Team Korea has said, well, look, if we can do all this skeleton, a lot of the internal organs of the body are similarly structured if we do it like this. Really interesting. We've got, IEEE, I can't even count them all, but there's at least a handful of references. We've got distributed interactive simulation protocol. We've got, floating point. We've got other things. We follow IEEE standards wherever they exist. We have rigid body physics. Is it anywhere near as sophisticated as Unreal? No. Is it a basis? Yes. Is it connected and consistent with distributed interactive simulation protocol, which lets you share physics multicast regardless of whether there's a single server being the judge? I could go on. The party not at the table here is World Wide Web Consortium. HTML. Well, they argued for over 20 years, 25 years about hypermedia before Tim Berners-Lee said, well, here's HTML. And it took about 2 years until everybody's mom knew what click on the blue text meant. And we're still all going. And wait, there's more. We got the glTF. That we've adopted that lighting model. We can use the old and the new. Marius, good news. We retained the classic Vermeil encoding. We even retained the historic MPEG requirements. The door's open. We know how to play well with others. Maybe we should be dusting that off and upgrading it. There's more on the web stuff. Oh, WebXR. That just went to candidate recommendation last week. Translation. Stable. Everybody tests, make sure it works. Well, we already have 2 open source browsers that use WebVR. So it's stable. We can test whether it works as a roll-on top of Art. Let me try to share my slides and give myself a grade now. Did I cover everybody? Did I miss anybody on stage or anybody elsewhere? Forwards, backwards. Oh yeah, here's what we're not doing. We don't have to do the requirements that Metaverse Standards is doing. So, oh, good, because requirements is the hardest part. We are not waiting to answer your question, Marius. We're just adding it. And here's a lesson I learned from W3C standards building over the years. There are efforts there that have failed, or they reached a certain high level mark and then they didn't survive all the rigor and scrutiny and whatnot. And then a few years, they come back around again, a little different, and now they fit. Oh, so my lesson learned from that long, arduous process is when it's ready, it fits. When it's not ready, let's keep talking about it so we can make it work. We're going to keep going. Thank you.
Okay, thank you, Don. Yeah.
Yeah, so I'd like to give some positive example, which is not in the metaverse industry, but another industry, which is autonomous driving. So in the autonomous driving industry, everybody is using some standard talking about you are doing a level 5 autonomous driving, and my company is doing level 4, and her company is doing level 3. So those kind of level 0 through level 5 are specified by SAE standard, SAE GS3016, so which has been probably the most popular standard in the autonomous vehicle industry. I think that is a very good example about standards could be playing a leading role before the technology is mature enough. So in old days, we typically talk about market-driven standards, which means as SDOs, we sit at home, we'll be passive, we wait for the industry to come to us with standardization proposals or requests. But recent years, there's a new trend that especially in terms of addressing emerging technologies. So there are more and more examples that the standards could play a leading role before the market, before the technology become mature enough. Standards could set up a roadmap or set up some like taxonomy or different levels, things like that for the industry. So that's, I think that is a constructive example, and we should pursue. And also, I think there are different types of standards. So in IEEE, we are trying to build an environment for thousands of flowers to bloom and let the market choose a winner. So it's not the end of the world if some standards do not work, some standards are not get widely adopted by the market. But I think we just, it's sort of like a venture capital investment, right? So you can't expect that all projects in your portfolio will succeed. But some of them, a few of them could be super successful, then you made your day, right? So I'll stop here. Thank you.
Okay. Yes, Chris.
I think it's inevitable, of course, that an industry crossover application is going to set the standards. The thing we're desperate for the metaverse is what on earth is going to take this into the consumer community. And we really don't know what it is. It's certainly not going to be computer games because computer games are paid by a small number of people. So is there a consumer application kind of like the iPhone that will take it across? What will get a 50-year-old lady to go into the metaverse? It's going to be something that improves the lifestyle. So whoever gets there first is going to define a lot of standards. However, we're currently working on probably current count about 50 hardcore metaverse projects across the industry with different companies. Every single one is covered by strict NDAs. But I see a theme across them that I've really never seen before, and that's the quality of workers and the quality of people that are working on the internet. Most have come out of a strong, usually certainly master's or PhD background. They all know each other. SIGGRAPH's been replaced by CVPR as the go-to conference about all this activity. The papers that you see there are absolutely stunning, but everybody knows each other. And so all the way across within these companies, you've got groups of people that know each other, sharing ideas. There's an informality. It's not actually discouraged. It really isn't. People move around projects. And I think this is something I've really never seen before in this industry, quite on this scale. And I think that is one of the things that's going to help enormously get continuity, interchangeability across companies, because they're going to be under the pressure to get something working, to justify the billions that are being spent on the metaverse and the time pressure going on it. Now, behind all of this is some of us out there have been preparing for 25 years for this. I mean, certainly X3D has, certainly looking at the MPEG presentation at the back of things, we've all been working out there. So instead of what we've always seen in the past, where the standards groups are running around saying, oh, what are the industry requirements? Well, they don't define them. Now let's have committee after committee to agree them. A hell of a lot is in place. And I think this is what's been so exciting about X3D is when I looked at X3D, this is the perfect container for an avatar. Everything's in there. How did I get onto X3D? Well, because I came across it as part of a medical standards group and working with a DICOM group. And that's how I know Don from that point of view. So I think we shouldn't be too worried about it. There are initiatives throughout the standards community that are going to come together within this. And above all, the people that are implementing the metaverse are used to networking.
Okay. Ralph, yeah, Nicholas.
Oh, you can go.
Okay. Yeah, so I think that the time is right, in fact, for doing that, because when you look the presentations this morning, in fact, also the Metaverse Standards Forum created in June with a few members, in fact, and now 1,900 member companies, I think it is. So it's enormous, in fact. So to see there's a very big interest. It is huge. And I think we all agree that, yeah, we are still asking the question, okay, yeah, what is the metaverse? So it will not be something that is black and white, in fact. It will evolve over time, right? There will be some aspects there in the beginning. We will have standards for that, depending on where's the biggest dynamic. And then there will be some other areas that will also evolve. So I see this something evolving over a long time, in fact. And besides the standards, we have always some big guys, some strong companies who create a proprietary platform and are also successful with it. Look, for example, the example of internet streaming. This is something started maybe before the years 2000, in fact. There were proprietary formats and it started slowly. The internet was very slow, quality was bad. It became better and better. And then, yeah, one day also the standards organization started. And today, MPEG is one of the very successful streaming formats, although that some proprietary platforms were there before. So I think this is the example. Okay, it's maybe harder to get really many people synchronized through standard. It takes longer time, but in the end, it can be successful. And of course, for me, this usually I've seen this in many other domains that suddenly there's an important topic and all want to jump on it. Many organizations are created and it's difficult to coordinate that. So if the Metaverse Standards Forum can help here, I think this is very beneficial. Thank you.
Great. Thank you, Ralph. Nicholas, you wanted to add something?
Yes, please.
Yeah.
Yeah, I think it probably is the right time, but maybe for some different reasons. You know, we've talked about the industry and the hardware engineering maturing. well, it does take an adult to, actually deliver on some of this lip service. So I was really pleased, to hear that people are talking about, baking pies and baking bricks in order to build bigger markets. Maybe this will be the time that we can stand behind those words. Thanks.
Good. Ingo, do you want to add something?
Yeah, we haven't talked much about the data provider side, right? I mean, we have big organizations or corporations that can build well, the avatars in the metaverse, but if you don't want to synthesize all the data, then you need to have the real data providers on board. And if you don't give them a set of standards to work against, I mean, how can they deliver all the data that you need to make the metaverse an exciting place? So I think there are so many levels, right? There are the technical streaming format levels. There are the concepts about space. There are the delivery mechanisms for IoT data or even remote sense data. I mean, there are so many different levels. And I think, yeah, there's always the right time to start with a standard, right? Because, I mean, how can there not be? The result will be that you go into various directions and then it takes a couple of years and then you come back together. And I mean, it oscillates, right? And so every time is the right time to start with it.
Great. I love your answer. Okay. Yes. Okay. Let's move on. I still have one question that is more technical that I prepared, and then I would also like to give the floor to the questions from the room. So let me display my last question, making sure that everybody can read it. So this is about, yeah, it's more technical. It's about examples of existing pieces of technologies or standards, if they exist, that can be already used as interoperability means in metaverse, or projects that you are working on, or you know that they exist, and with some adaptation maybe, or directly as they are, we can already use them to offer some layer of interoperability in metaverse. Yeah, who wants to start? Yes, Ingo, yeah.
Yeah, I think it's a very exciting question, right? Because on the one side, we could say we have already a working set of standards that you can use for those interoperability arrangements. And at the same time, if I look at it from OGC's perspective, there are these questions: to which extent do we need to extend our standards, right? Our current standards, our current concepts about location are basically replicas of the real world. But the metaverse gives us all the flexibility. So if I mean, the concepts we have right now do not include things like teletransporting humans from A to B. But in the metaverse, we could, right? If we decide this is an option, okay, go for it. And even space has a complete different meaning, because walls are not necessarily things you can't go through anymore. And if you want, you can go through the wastewater pipe and experience a complete new world, right? I mean, there are new ideas that we can explore, and I think, at least from the geospatial, from the location perspective, that's a very exciting field, because we can play around now with the ideas and the concepts we have developed over the last couple of decades, and see how we can modify them to create a world that we actually like to see.
Cool. Okay, Ralph. Yeah, we have
just some information on the concerning compression. In fact, so what Marius presented, the point cloud compression that has been specified in MPEG. So the spec is ready since July 2020, and it's not only the compression part. So they also specified the associated file format, the transport protocols. So for example, can be delivered over Dash. And then very interesting aspect is also the implementation, because we have heard that this is that the 3D volumetric content is projected to 2D planes, and then it can be transmitted as individual videos. So in this case here we need minimum 3 videos. And interestingly, an off-the-shelf smartphone that you can buy today, it can decode a number of videos in parallel at the same time. It's amazing, but it works. So we made some prototypes, and I will show that also tomorrow in the demo session. So for example, this VPCC, as it called, video-based point cloud compression, it can be implemented on a smartphone. You don't need any specific hardware because these video decoders are implemented in hardware. So all this is running in real time, 30 frames per second. And just by software. It's a little bit software that you need to coordinate all this and to do the reconstruction in 3D and the rendering. And interestingly, this does not drain a lot of battery because often, okay, when you have a software-centric things running, also to use the GPU, this drains the battery. But because of this usage of hardware, in fact, in the device of the video codecs, the battery consumption is very low and it runs for hours. So, so if someone can or has already pre-produced content in form of point clouds, this can then be overlaid, for example, with what is coming from the camera in. You have this point cloud person then in front of a real scene, and it looks pretty good. So we think that people, you have app developers who are very creative. They can quickly find some good ideas to bring some good applications to the market. The next step is then really also from the phone manufacturer side, to integrate volumetric cameras. That maybe that really what we see here can be captured, in a volumetric manner. Of course, if it's in the front, they cannot capture my back, but it can capture it a little bit from around. And when you move, really, okay, you can. It's much more realistic than just to the video. So this is at least a first thing that can be tried. We have also an implementation on a little game console, for example, NVIDIA Shield. It's also working, in fact, on that. So the good thing is that this codec, you can easily bring it to devices that are already on the market because you don't need any special hardware for it. And this is pretty important. So it's a starting point that can be used. A little bit what we had many years ago with video, with 2D video, we had MPEG 1. It was a starting point. In fact, digital video was starting. It was not yet the big success, but people understood, okay, hey, this is much better than analog video. And here we will see, okay, hey, this is much better than just 2D because we see something in 3D. And then we will see over time how it evolves. But this is, I think, that can be quickly implemented. And we have also, for example, typically MPEG is doing these core standards, and then you have other organizations that bring it to deployments. For example, for television, it's DVB in Europe, it's ATSC in the US, and it's SPTVD in Brazil and South America. And interestingly, SPTVD, they have already selected the VPCC system for usage within their new television system so it can be used there. It's currently in progress with the specification, but we have this first selection. There's also a second MPEG standard MAV. This is more for 3DOF Plus that you can just 3DOF is 360 video, and 3DOF Plus means you can use the parallax and move a little bit around. So this is also implementable, and also Brazil had already selected that for their new television system. So these things are moving. It's just, I would say, one vector in one direction. There's certainly other things happening, but this is something that could be quickly have some first success. Thank you.
Yeah, good to put us on the floor again, because it's something that we have the feeling that the physical world doesn't matter too much. We just program computers and they are able to do whatever we want. But hardware acceleration is something very important, especially for the mobile devices, for their battery constraints. Okay, Nicholas.
Oh, thank you. Well, I would just like to share maybe as a little bit more of a story, right, about sort of the reality. Okay, so just a real quick check. Late 2010, we built 3D Blacksburg. Okay, this was with geospatial data. It was the pipes from the town, the university, laser scan drones. Okay, it was curated. It was hand took a lot of students, you know, tweaking things, even SketchUp models. But once that was there, and I can tell you it still runs today, and I can put glTF models anywhere I want. My students can fly around and chat. We can put real QR codes in our art center and have the digital content, you know, right immediately available. So I think what I really wanted to say here is that this is a key piece. I think it was Ingo also about this extensibility of the standard, and this is something that X3D has paid forward with us. We picked the greatest common denominator. We said this gives us lights, it gives us interaction, it's going to be around for a long time. And then, you know what, we extended it. My students thought of a great new idea for a node, and we can implement it, you know, and it's still X3D, it's still valid. And so when extensibility is built in, you have this positive reinforcing cycle. And this is one of the things of, you know, we're able to touch now all kinds of domains because we've chosen that, right? We have civil engineer students designing light rail for their thesis project. It's in 3D Blacksburg, okay? It's using the latest 3D models from the scans and from the CAD BIM as built. This is already, you know, 12 years old. It's still working. It's delivering results, and it's evolving at the same time. So I think that's just as a proof of existence that maybe technically, again, it's not the hard part. I think it's the social and willingness, again, adulting, to want to play well with others this time. You know, how much money are we going to burn next? We've seen many generations of great content and companies go, you know, the way of the grave. So maybe it is time. I hope so. Thank you.
Okay. Mark, you have an announcement about Unreal becoming a piece of metaverse for everybody. Open.
No, but
okay.
It's pretty open already. I mean, you know, you should read the license agreement. It's not open source license agreement, but it's a very, very generous licensing agreement. But your question was, you know, are there, you know, working standards in the metaverse? I can share some data to illustrate this conversation. You know, we operate Sketchfab, which is the single biggest place on the internet when people show and share 3D models. We have 10 million users on this platform. They've been, as the last count, the team is in Paris. I did a review with them yesterday. We're close to 5 million assets on the Sketchfab repository, mostly public. Some of them are private. And the top 3 format, 90% of the transaction on Sketchfab are done within 3 file formats. And those file formats are FBX, glTF, and USD, with OBJ a distant fourth, and virtually nothing else. That's what people do when they do 3D on the Sketchfab platform.
When you say operate, what does it mean? I don't have.
Well, they upload and download all the. You know, we track the formats and the host application where the data come from. Mm-hmm. We track the host application and the format that is used to exchange the data.
Okay, okay. And can we import that objects directly in Fortnite?
So to get to Fortnite, you need to go through Unreal Engine, and Unreal Engine supports virtually any formats that through different kind of connectors. Okay, so technically it's possible. Something else is keeping us without not doing it. And Sketchfab is not primarily for Unreal Engine users. I mean, the Sketchfab servicing all 3D community. There are people doing scanning, people doing cultural heritage, people doing development, people doing games. I mean, you'll find as much use of Sketchfab with Unity that you'll find with Unreal Engine or with, you know, Play Canvas or, you know, 3.js or all kind of thing. I mean, it's the YouTube, it's the universe. Right now, it's the single sharing site for 3D content. There is no other place when you can go and share 3D content for free. So that's the role that Sketchfab plays into the ecosystem. So it's not related at all with Unreal Engine. It does work with Unreal, but you know, Unreal Engine doesn't have 10 million users just yet.
So that was just a provocation on my side to create something there and then to sell it directly in Fortnite. I don't think that will appear quickly, but That was more a provocative question.
Yeah, but you know, I heard a lot of definite statement on this panel. I'm actually quite surprised about how many formed opinion there is around this table.
Okay.
Knowing that we don't know much about the future, you know, we all have crystal balls, have anticipation, but I'm surprised by the level of determination that I hear.
Okay. Julien, you want to say something about IEEE standards that can be used as they are today for Metaverse, or good candidates, or that require some adaptation, but still something that can be a starting point?
Yeah, so we will talk about standards for Metaverse. We need to understand that there are many aspects. We're talking about the infrastructure supporting Metaverse from that perspective, like Wi-Fi, Bluetooth, those could be enabling supportive standards for Metaverse. Or are we talking about content? Are we talking about applications? So there are different aspects, different dimensions at different layers. So I may share one slide. I don't know if I can do that or not. So
yes.
Which is about my view about okay, you can say that, right? So this is my view about the Metaverse standardization needs. So I think we start from fundamentally terminology, definitions, and taxonomy. And on top of that, there are at least 3 different pillars, technologies, which would include interoperability, interfaces, formats, functions, performance, safety, security, identity, and privacy. And especially when we are talking about the Metaverse, we also need standards for content, like content descriptors and ratings, because Metaverse is super powerful in terms of providing the immersive experience, which could be like really risky or even harmful. So we need some standards for the content as well. And also we need to address the social implications like ethics, ESG, and SDG perspective. And on top of that, there are many applications in different industries or different use cases. For example, transaction of virtual assets, we also need some standards for that. So I'm not saying that we need to do everything from scratch. There are already many existing or ongoing standards or standards projects. So we need to identify them, so we don't need to reinvent the wheel. And I know Metaverse Standards Forum, they have an effort in identifying those kinds of standards and projects. This is very great. And I think on top of that, we need to identify gaps and the needs, what we need to further refine and develop for the big picture of Metaverse. Thank you.
Yeah, thank you for the slide. It looks like a nice backbone for Metaverse Forum to build on top of. Okay.
Yeah, absolutely, it's a really good one.
Yeah. Okay, let's have some questions from the floor or from. Yeah, Don.
Do I get to answer your question?
Yes, please.
Okay, merci, monsieur. Really loving it, all of y'all, and it's so much great stuff. And Nicholas, I'm seeing direct echoes of what you were saying about ethics, social responsibility in the IEEE slide. That's perfect. I'm not sure we have a paper in the program, Marius, but headsets are not necessarily safe. People get sick. People can fall into a hole. People can cause other things. Who's in charge of that? Still out for debate. If you ask what's the most exciting thing, that's easy. It's the web. It's the web, and people can count, users or markets or community. But quick show of hands, who's not on the web? To me, our target audience is everybody on everything. And so that's what we've designed for. That's what we're going for. I'll attempt humor. This is a big mistake, but I'll attempt it because humor doesn't translate across languages. But sometimes we get so serious about what's the most important, we forget that it's all important if it all has to work together. So the restaurant joke is, when people complain about the food, they say, yeah, the food is terrible, and there's not enough of it. So we might be in that situation right today. We've been maybe in that situation for a while. Web is the most exciting thing. X3D4 has turned the corner from trying to integrate many, many needs. We're stable. This next year for us will be executing, using Metaverse Standards Forum priorities. What is identity? Oh, that's good. Working, building, continuing with our liaisons with others. For the web, that's what we're up to. Very grateful to hear everybody today. Thanks, Marius, for your panel.
Okay, thank you, Don. Okay, let's have the room speaking as well. Yes, Indira, you need a microphone.
Thank you. Thank you for all what I've heard, and I'm very interested by all of your commentaries and what you bring to this community. My comment is that for me, Metaverse could be a social engine of transformation. Instead of seeing the Metaverse and the society apart, we could see it as a way to think differently. And the questions about the human being comfort and health has been explored through this workshop yesterday afternoon. But there are many, many questions and problems about how people from different countries, this has been already mentioned, different countries won't need the same metaverses or won't have the same possibilities to access the metaverse. And also, what do we want to share? For example, if we have our avatar, we have to cross the embodiment question, first question, then to have social interactions, not only with other avatars, but maybe with agents. We never mention agents, but it is part of the metaverse. And what are the rules, again, for agents? Do we have to translate and transpose exactly what our real world is made of in the metaverse, or do we have other purposes? And these questions should invite us to work together. So I see different part of the work, because we are working, for example, on the Continuum project for the continuity of interaction and devices. For example, if you take a smartphone, then you take your head-mounted display, then you take a cave. What will be the impact? How can we use the metaverse? But that's not the only problem or possibility. We may have also to share metaverses for different purposes. So, of course, it will be possible to get different platforms. But, well, I think that we should include people from the different communities to think with our community.
Okay, I think we all agree. And we observe this during these days that we are also addressing as problems. Yes. Yeah. I saw your hand, Chris.
I think that's I think this particular comment is marvelous because it brings in inclusion, and there's no question we have to treat the metaverse as a worldwide asset, not just for the rich countries, not for the poor. The other thing I wanted to say in the last session, but I think this is a good introduction for it. The key thing about people in the metaverse and avatars, even if an avatar is derived from volumetric data, which has very little ground truth in it, at the end of the day, it's crawling with biomarkers. And what we're going to be roaming around on the internet is going to be a medical quality record in some shape or form. Even if we're looking at texture in 3D, we can ascertain if somebody has sleep issues and so on. So I think we've got to be prepared for the fact that if the avatars are going to be realistic within that environment, they're going to be containing medical data. The most sophisticated avatar project that I've ever worked on was, it didn't make it, but it was a business of Craig Ventnor's Human Longevity Project. And it was a pretty cool thing. You could fly in your helicopter, not very inclusive at this stage, spend $50,000, go to San Diego, be scanned in every medical technology you could ever imagine, have your DNA analyzed and so on. And the whole thing was presented in a 3D body skin, which if you were wearing very little clothing, would also actually have a lot of biomarkers on the skin as well. That to me is how we've got to think about an avatar. And when we start looking at the power within that, particularly if we add movement and elements of that on top of it, that's amazingly powerful data. It needs to be protected. Now, I think there's one piece of good news on this when we say, how on earth are we going to protect all this information? Well, I think Yu's analogy of the driverless car was excellent, because those levels pretty well map on to the traffic regulations that exist across the world. I mean, basically, you're fitting on that. So I think that we've got to look at Avatar as a lot of the existing privacy and things like HIPAA in the US, GDPR, medical in Europe and so on, they actually apply to that. So I don't think we're going to see the politicians running around in circles saying, what the hell do we do with it? But it is incumbent upon us as an industry to figure out how we're going to protect those, put the security on, whether it's blockchain, NFTs or whatever. But it's back to everyone owns their avatar. You then have digital rights management on that. You release that for a limited period of time for somebody to use. If it's social, I want to get out of that room just like I walk out of a party. I want to get rid of, I don't want that avatar there. On the other hand, I want to give that avatar to my doctor to help me get a better life. And that's how we have to be thinking of this going forward. And that is so important, that's inclusive across the world.
Okay. Yes, we have a question, Monica.
Yes, so just to ponder a little bit more on this definition of the metaverse, I can see that now we work with this priori assumption that we are trying to bring this world to the metaverse, so basically replicate everything. But as we replicate everything, if we, for example, model the car, we may go into this uncanny valley that I model the car so perfectly that now my user can feel the same pain being stuck in the traffic. And so as we build those definitions, shall we maybe rethink the interactions, and as we build the standards, bring a bit more of humanities and social sciences, so when we build the model, we exactly know what to expect from that? What's your thoughts?
A challenge. Someone tries an answer? Yes, Nicholas.
Well, I think this is a great comment. You know, a lot of our discussion, and we're just a little bit waking up from this, you know, as engineers, this blinders in a certain way to the fact that, yeah, you know, there is a whole world out there. It's not just Silicon Valley and high-end industries. This is something transformational, and I think we need help there. You know, there's these issues have been wrestled with in literature and philosophy, and you know, maybe we could learn something with a little bit of effort. So I think this is a great idea. The humanities are, you know, unfortunately they have this also the challenge of, you know, the barrier to entry. So a lot of them sort of ended up in Second Life, and that was a good place to get your feet wet and understand some of the implications of the technology. But I absolutely agree, and maybe that should be a focus for some future sessions, at least in this conference and maybe some other venues. There's plenty of dystopian versions out there, right? I'd like to see a positively framed one. So thank you for that.
Yeah, at least if we don't like our life, we can have some other better lives in different metaverses. That is a hope. It will never happen. We'll be the same unhappy as in the real life. Okay, go on.
I just have a thought. I think it was Chris that said, well, what's it going to take to get 50-something women to join? Well, being in that category, why don't you just ask me? I mean, I look at around the room and I'm like, okay, it's mostly guys. There's only 6 women here. What are you going to do to make it comfortable for the women. And by God, we can spend a shitload of money and we can monetize the hell out of anything. So if you make it comfortable for us, we will drop the cash. I don't know how more simple to make it for you all, but think about how you make it safe. I mean, we were talking about walking home last night. I needed a ride because I was female and it was dark. Now, when I was in Barcelona this summer, the women were out at 10 p.m. I'm asking you the same question. What are you doing to make it safe so that I can feel free to spend as much money as you all would like me to?
It was also a pleasure for me to drop you at the hotel. So.
It was, thank you. I do appreciate that. But but you understand the attitude. I mean, and that's what I'm saying. What are you going to do? Have you asked the 50-year-olds what's important? Have you brought in people to the conversation that you haven't thought of before? They're not all 6 foot or 2 meters males. You know, what are you going to do that? And I think the metaverse will take off once you've done that.
Great comment. Thank you. It's no doubt, you know, a challenge in terms of getting this diversity and representation in certain fields. But I think what we're advocating really is, and of course, there's certain ways to move the needle here, but that was the kind of requirements I was talking about, is user-centered design, right? What is this thing going to be good for? Is it just a game? You know, is it something, a social thing? Is it part of my work? Where, you know, what is it for? And I think that's got to be, you know, when we're doing any kind of social science or surveys, right? We've got to be able to have represented groups with a voice. And I would just love to have more of the technology driven with user-centered design instead of this sort of top-down, technologically centered model. So thank you for that statement. I think it's an important challenge that everybody here is probably appreciates.
Okay. Other questions or remarks or challenges? Yes, Ralph.
Yeah, concerning safety and security, I can only agree with what has been said, in fact, and that because, okay, we all think, okay, that, okay, the avatars need to look nice. I think, yeah, we like that, in fact. But in the end, if the platform is not safe, I think private users will not use it because, okay, identities are stolen, in fact, or deep fakes, in fact, even happening in 2D today. And this is very, very dangerous. And I think the risk is even higher, in fact, when we have the metaverse. So security is really one of the first things that also probably need to be coordinated, that this is there from the very first time for private users, also for companies, in fact. So when you look, for example, with the MetaQuest platform, you have applications for virtual meetings, in fact. And you have all the guys of your team sitting around the table. You have all these avatars around it. In fact, it looks very nice. Of course, the avatars don't look so good today. We would like to look them better. But the big thing is really security. Okay, is it safe that you can discuss company internal stuff within that meeting? In fact, and that so these things will only be used, I think, by private users, also by companies, if this security problem is solved and we have confidence in it. Thank you.
Good. User-centric design and pay attention to user rights. Yeah, we are in France, so we are able to do revolution at any time. Good. Thank you. Yes, who wants to say something? No? We. Yes.
I just wanted to add some.
Yes, please.
So well, we talk about the user-centered design, but in IEEE we have a different term. We call that ethically aligned design. So we have developed a series of standards for artificial intelligence. So I assume we will need standards for ethically aligned design for metaverse as well to address those kind of very important issues. Thank you.
Yes, Chris.
I think Carol's point is excellent because that's exactly what we need to be looking at is there. But I have a particular favorite concept that I've been talking about, what I call my guardian angel avatar. And this is the reverse of the metaverse. It's actually when we go into the driverless car is how the hell are we going to deal with cities? We're pretty good at recognizing when you've come out of the restaurant late at night that we may be staggering across the pavement or the sidewalk and somebody's there, but the driverless cars get a bit of a problem with it. I would love to donate an avatar that could apply the effect of drink upon me so that every driverless car coming down the street would recognize that I may not be as complex as I would be 3 or 4 hours earlier. So in other words, we mustn't forget, and Carol's point actually was there, the backwards and forwards between the metaverse and the real world. We are trying to create a seamless environment, and sometimes we focus a little too much on what it's going to be like entirely in a virtual environment. Let's think also about how we're going back in the other direction, and I think that is a very key essence in Carol's point.
Satisfied, Karen? Yes. She shakes her head. Good. Okay.
By the way, I know what she wants at shoes. We've had this conversation many times.
Good. I think that we can continue for at least 1 or 2 hours, but we have to stop because we have some coffee waiting for us. So thank you all for the participation. Was great to have you virtually with us, and of course thank you Ralph and Nicolas. They will stay with us for the coffee. So I would like to close the panel session here. Thank you again, and we will continue in half an hour after a short coffee break. And the next session is also on metaverse definition and characteristics, and some of the social aspects will be addressed in that session. Okay. Good. See you in 30 minutes. Bye, guys.
Thank you. Bye.
Bye. Thank you, everybody.
You have to switch it on. No, just you have to keep it for 2 seconds pressed.
One.
Hello, I'm Anita.
That was another.
I guess if 2 mics are on, then you start recording.
Marius, c'est celui-là qui a un micro ouvert, celui là-bas.
Hello. Hello. Hello.
Did you take the adapter? Adapter, did you take it? Hello, can you hear me now, Don?
Yes, I can hear you.
Okay, thank you. That's it, everybody.
2 more to come.
Yeah, okay. So, hi, my name is Johannes Beer. I'm the chair for the session now, and I'm really pleased because I am really lucky. All the presenters are in the room, so not remote or anything. So we're going to have 1.5 hour, 3 presentations each, about 20 minutes plus questions, and Anita is the first one. So it was the keys to an open, interoperable metaverse.
Hello, everybody. My name is Anita Havele. I'm the Executive Director of Web3D Consortium, and I'm here today to present our paper, The Keys to an Open, Interoperable Metaverse. I would like to acknowledge and thank my co-authors. Nicholas Paulus is here, Don is online, and Bill Benman, who's in California right now. We all got together, and one of the reasons we thought about writing this paper, because there was so much happening with the metaverse, there was so much confusion. So we thought, since we've been doing this for 25 years, maybe we can help with this confusion. So that was how this paper started. So the term metaverse has taken a new meaning and interest recently. Everybody seems to want to name their platform the metaverse. We saw that in all the presentations this week. Everyone wants to, call their product the metaverse, which has resulted in a great deal of confusion among producers and consumers. With this paper, we seek to address this confusion and discuss a workable definition. We don't know if we are ready for a definition right now, but we have to start somewhere. So we said we would come up with a workable definition, which may need some tweaking, but at least a start of what we think the metaverse should be or will be this time around. And then we'll be discussing the key issues around this definition. So as we saw in Mike Zaida's presentation yesterday, let's name everything the metaverse. Everything is the metaverse now. So what I'm going to start with is a little bit of the history and background, then cover its current status, outline some key issues, give you a workable definition, discuss what is needed, and then present an example of what's available today, and then finally address the future. So as we all know, most of us here know that the metaverse has existed since the 90s, and now it's in the 4th generation. Okay. Many focused on monetizing these proprietary worlds, They were mostly games and social platforms. Many of these VR worlds do not exist today. They are gone. Now, building a 3D is very expensive. Building 3D twice is even more expensive. So like in the panel session, what was discussed is how do we protect our content, reproducibility, and that didn't happen. We lost everything that was built in the 90s and even the 2000s. But the Web3D community was building 3D worlds. And we were calling it real-time 3D in a browser with plugins because there was no native 3D available in the browsers. We have that today, but in the 20s, we were still building 3D in a browser, but with plugins. And then we had this 28.8 modems. So there were no affordable CPUs. Headsets were so expensive, but it was an aspiration to have this one world where we could share 3D worlds with each other. It was still a vision, and using the W3C standards, HTML, X3D, VRML, we were trying to build these worlds. We were using GIS data, HNM, multimedia, archival 3D. So this is the world that Nicholas built in 1998. And today he can use the same world in his cave at Virginia Tech. So these worlds still exist because they were built on open interoperable platforms, and they played well with the ecosystem. So what is the current status? There are several walled gardens, mostly in the gaming and social platforms, very few commercial and professional applications. With expensive VR sets, headsets, AR glasses, and most platforms are proprietary, they are all locked. I mean, if you are in one platform, you're stuck with them. And also, another problem is user devices. The VR headsets, AR glasses, they are expensive. There is cyber sickness, there's visual strain. So all these issues is that was the reason why we couldn't manifest the metaverse in the last 20 years. So can we do it this time around? Let's hope so. And we look at what are the key issues to make this happen. Second Life is still in use, but it certainly failed to reach the masses. Hopefully, like Mark Petit said, he thinks it's going to come back. Let's see what happens. So where are we now? So to create virtual worlds today, we need to mash up data from different 3D assets, different formats, and then we have to present them on different platforms. That is the reality today. It's not like one asset, one platform. So it has to be interoperable, and user experience today is not easy. Many proprietary headsets and devices, security, very little awareness for metaverse safety, security, privacy, and ethics. Nobody's talking about ethics. So I think now is the time for us to bring all these discussions up. Many specifications are available today, but few global standards available that are interoperable.